Today we discuss one important topic related to inner product space related to bilinear form. Okay, we also known about definition of bilinear form and related theorem example and obviously some basic definitions of sum operation and scalar product operation. In previous class we also discussed those ones. Today we start from one theorem. Okay, we write this statement of this theorem first, then going to discussion forward. Okay, so we write it now. For any n-dimensional vector space, for any n-dimensional vector space V, okay, over F and any order basis beta for V and any order basis beta for V, okay, here psi beta BV with set of all binomial from on V to M n cross n if this matrices is an isomorphism okay, we have to discuss this one now. So what we do, we also known about that this psi v of h equal to what, equal to here, that means psi b of h equal to, here we write some matrix psi beta of h equal to some matrix A, where aij equal to h of vij, okay, for ij equal to 1 to n. Understood? Then we known about that what, then this one, this psi beta v linear, okay, not a problem at all. This one happened. Now we have to show that what psi beta is 1 to 1. Okay, first we show this one, then what we do, we also write it now in this way. That means suppose that here psi beta is equal to 0, okay, then we implies that is equal to 0. This implies, that means psi beta is 1 to 1. Okay, so we'll suppose that this one for some age belongs to bv, okay, understood? Then what happened, then fix pi belongs to beta, what happened, and the mapping here L of vi, okay, L of vi such that v to f which is linear, okay, which is linear. Then what happened, that means by hypothesis, okay, by hypothesis L of vij equal to h of vij, understood? equal to 0 for all Vj belongs to beta. Okay, hence what happened, hence we erase our portion and going to further discussion of that. So what we know about that, this one L of Vi equal to this one. Okay, age of Vi Vj for all Vj belongs to beta. Hence L of Vi is the zero transformation from V to F. Okay, from V to F. So what happened? So here age of Vix equal to what? L of Vix equal to 0. Okay, for all x belongs to V and Vi belongs to beta. Okay, that means here by hypothesis this one happened. Age of Vj equal to 0, then age of Vix equal to 0 for all x belongs to V. Okay, now next for fixed and arbitrary y belongs to V. Next fixed and arbitrary y belongs to V. Then what happened? And the linear mapping, okay, linear mapping what? Ry V to F, Ry here V to F. Okay, defined y here Ry Vi equal to age of Viy. Okay, equal to 0 for all Vi belongs to beta. And hence Ry is the zero transformation. Okay, so what happened is here, so h of xy equal to, okay, ryx, understood? Then this one equal to what? This one equal to 0 for all xy belongs to V. Okay, then what happened? Then we start from this one. Okay, psi beta is equal to 0 implies that a is equal to 0. So what happened is here, so we get h equal to 0. Okay, then what conclusion we write now? We write this one. So psi beta b 1 to 1. Understood? Not a problem at all. Now we're going to psi beta is on 2. We erase that portion and discussion of that. Okay. Here we have to show that psi beta is on 2. Okay, then what happened here? Consider any A belongs to M n cross n if. Okay, and recall the isomorphism. The isomorphism, what here phi beta, okay, v to fn, okay, defined phi beta here. Here phi beta also defined in this way. Okay, for now this one discuss here. Phi beta, the isomorphism phi beta is v to fn defined by, okay, defined by what? Defined by phi beta x equal to here x beta with respect to beta. Okay, for each x belongs to v, for each x belongs to v, this one happened. Okay, then what happened? Then we also discuss in this way. Okay, phi beta v to fn is this one. Then for x belongs to v, okay, for x belongs to v, phi beta x belongs to fn. Okay, here as a column vector, as a column vector. Understood? Then what happened? Let here h to h v cross v to f, okay, be the mapping defined by, be the mapping defined by what? Here we write h of xy equal to phi beta x transpose, okay, a phi beta y for all xy belongs to v. Okay, then what happened? Then so we can prove that h belongs to, we have to prove that what? Here h belongs to b of v. Okay, then this one equal to, we show that what? We show that psi beta is equal to a. Understood? Psi beta is equal to a. Now what we do here, psi beta is equal to a, let vi and vj belongs to beta, then here phi beta of vi equal to ei, okay, and phi beta of vj equal to ej, okay. Hence for any I and j, hence for any I and j, what happen is here h of vi vj equal to here phi beta of vi whole transpose, here e and phi beta of vj whole. Okay, then this one equal to what? This one equal to ei transpose aej equal to what? Equal to aij. Understood? Then what happened? Then this implies that, okay, phi beta of h equal to a. not a problem at all. Okay, and phi beta is 1 2, and psi beta is 1 2. Psi beta of a is equal to a, and psi beta is 1 2. Understood? I think all are understood this one easily. Okay, so we also that means discuss too clearly that this one is psi beta is 1 2, and again we also discuss psi beta is 1 1. Okay, and psi beta is linear, so psi beta is an isomorphism. Okay, so we also prove this theorem. Now we discuss one corollary related to that. So now it is that portion. I'm going to further discussion of that. Okay, so we now write it here. That means psi beta is linear 1 to 1 and 1 to, hence psi beta is an isomorphism. Okay, now we discuss one corollary here. Corollary 1. Okay, for any n-dimensional vector space V, for any n-dimensional vector space V, okay, BV has dimension, BV has dimension n square. Understood? Then this one have not a problem at all. That means BV equal to the set of all bilinear forms on V. Okay, then this one have dimension n square. Okay, if V has dimension n square, then BV equal to what? The set of all bilinear forms on V. That means here if those functions from V cross V to F. Okay, that means BV equal to what? Those BV equal to set of all bilinear forms. That means H belongs to here this one BV. Okay, such that H equal to V cross here this one H V cross V to F. Okay, and satisfies and obviously BL bilinear form, B bilinear form. Okay, here this one H such that this one happen. Okay, then set up all bilinear forms on V. Okay, understood? And then we also discuss this one. That means BV has dimension n square. Okay, for if V has a dimension n, then BV has dimension n square. Understood? Now we also discuss another corollary related to that. Okay, another corollary is here. We write it. Let V be an n-dimensional vector space over F. Vector space over if, okay, over if with order basis beta, with order basis beta, okay, if H belongs to BV, okay, and A belongs to, and A belongs to M n cross n if, understood? Then what happened? Then psi beta is equal to A, here if and only if what, hxy equal to here phi beta x whole transpose here A, and here phi beta y, understood? For all x y belongs to V, okay. Now we have to prove this one, okay. So also going to discussion about that, okay. Now BV has dimension. In previous one we also discussed BV has dimension n square, means BV have some basis and basis is contained n square vectors, okay. Then that means this one also represent, this basis also represent this H, understood? If he has dimension n, okay, V have dimension n, then this H, that means BV have dimension n square, okay, and this H also represent by this basis of BV, understood? Since why this one happened, too easily we also stand from this theorem. We known about that, that means this BV is isomorphism to what, mn cross n if, okay. Then mn cross n have dimension what, mn cross n have dimension n square, that means cardinality of mn cross n have equal to n square, okay, dimension this one. Then what happened, then we also talk about that, okay. This one, that means BV have dimension n square, understood? And now we discuss this one, that corollary to VB and n dimensional vector space over F with order basis beta, and if here H belongs to this one, not this one, is just dimension of this one equal to this one, understand square. So here let V be an n-dimensional vector space over A with order basis beta, and H belongs to BV and A belongs to this one. Then psi beta A is equal to A if and only if H is represented in this way, understood? So we now discuss it using this theorem. So this one is, I think, easy topics, okay. So in theorem we also do it, that means how this one in theorem we also do it, we discuss it now. That means in theorem we also do it, here is V cross V to F, okay. What happened, H of xy equal to here phi beta x whole transpose A and phi beta y, understood this one? So in this way here also we do it, okay. Then how this one happened, well, so that means we taken this one, that means for x belongs to V, this one happened, okay. phi beta A is equal to A, then this one is happen. Psi beta A is equal to A, then this one happen. Okay. How we also discuss it in this way, that means h of pi and pj equal to what? Equal to psi beta of pi whole transpose a phi beta of pj. Okay. Then this one equal to ei transpose a is equal to aij. Understood? Then this one happen, that means if this one occurs, then this implies that h here phi beta a is equal to psi beta a is equal to a. Okay. And again, if psi beta a is equal to a, this implies this one happen. H of pi vj equal to this one, and then this one happen. H of xy equal to this one. Understood? That means if this one happened, then this one equal to a ij, then this one equal to this one equal to this, so h of xy equal to this. Understood? Since vi and vj are arbitrary, so this one happen. Okay, so now we erase that portion and going to discussion another theorem related to that, another corollary. So that means this one also same, but we now write this one here. Here corollary 3, let f be a field. Okay, let a be a field. Understood? And n be a positive integer. N be a positive integer. Okay, then what happened? And beta be the standard order basis for fn, and beta be the standard order basis for fn. Okay, then for any age belongs to b of fn. Okay, there exists a unique matrix A. There exists a unique matrix A. Okay, belongs to M n cross n if here A, namely A equal to psi beta h. Okay, such that what? Such that h xy equal to x transpose ay for all xy belongs to fn. Understood? This one have not a problem at all. Okay, so we also discuss f be a field and be a positive integer, and let beta be the standard order basis for fn. Then for any h belongs to b of fn, there exists a unique matrix A belongs to M n cross n f, namely A equal to psi beta h, such that h xy equal to this one. We also discussed this one. Just here a unique, okay, a unique matrix. Obviously we see about that. What that means? If h of pi pj, then what happen is here h of pi pj, then here psi beta of pi transpose a psi beta of pj. Understood? then what happened? Then this one equal to what? Here we write ei transpose a is a, and then a I j. Okay, then also talk about that if, that means if this one happen, that means if another one also happen, if psi beta in h equal to, if psi beta is equal to some c, then what happened? This implies that h of vi pj equal to same cij. So aij equal to cij. Okay, then what happened? Then a equal to c. So unique a possible. Okay, understood or not? I think all are understood this one. That means how we write this one easily. Okay, then we're also going to discussion one example related to that topics. Okay, we now erase that portion and going to discussion one example related to that topics. Understood here? We write now example. Here define a function h, define a function h r squared to r squared to r. Okay, by what? By here h of a1 a2 b1 b2 equal to what? Date of a1 a2 b1 b2. Okay, here equal to a1 b2 difference a2 b1. Understood? For a1 a2 b1 b2 belongs to r square. Okay, then what happened? It can be shown that h is a bilinear form. Now we have shown that what? h is a bilinear form. Then we also find one matrix h be a bilinear form. Okay, then we find what? The matrix A. The matrix A. Okay, such that hxy equal to h transpose ay for all xy belongs to r square. Okay, since here aij equal to h of ei. Okay, then what happen is here for all I and j. Okay, then we have what? We have here a11 equal to date of here what? 1010 equal to what? 0. Understood? And a of 12 equal to what? Date of what? 1001 equal to 1, and a of 21 equal to what? Date of 0110 equal to here -1. Okay, and a of 22 equal to what? Date of 0101 equal to 0. So therefore a equal to what? A equal to 0 1 -1 0, this matrix. Okay, so today we discuss one important topics related to bilinear form, especially bilinear form we define some functions psi beta, which are, that means be an isomorphism from bilinear from on V set to the mat n cross n matrices over F. Okay, so we also give related corollary theorem and example. So I think all are understand this. If you get this type of video, please subscribe my channel, and if you follow this channel, see this video regularly. If you want to give like, please click on like options. If you have any questions, comment, suggestions, write it in comment box. So today I stop here. Thank you.